condition. So until the condition is satisfied, so it will execute the task within the subplan. So whenever the condition gets failed, it just come out of the subplan, right? So with this looping plan, so we just discussed on the loop concurrency also. So how do you run the task within the subplan sequentially and concurrently, right? So after this, we discussed about the methods as well. So methods within the task. So within the task, we can have methods. So we have the different methods that gets invoked. So before executing the actual task, right? So we have the at trigger method, then at start method. So then at success method. So we after at success, sorry, after at start, it is a perform method. After perform, it is at success. In case of failure, it is at failure, and in case of shutdown, so it is at shutdown. So in case so if we have to I think, yeah, these are all the methods. So these are all the methods that we have. So we can make use of these methods within a particular task. So within each of these tasks you have these methods. So what we have to do is we can just go to this task tab, and then we can just add the method. So once you add the method, so we can write a program, so that so the program or the script will get executed so whenever that particular method is invoked. When that method is invoked, so that particular program or script will get executed, right? So these are all the things that we discussed, right? So with this, right? So and I think so, and we have discussed on few use cases, right? So probably the use cases are, so how do you run a list of pieces sequentially or concurrently? So then on I gave you the questions to run the list of pieces sequentially or concurrently. Then how do we run a graph task between a particular time, between a time window? So if I have to run the job, so how do I run the job? So like this, I have given some assignments. So probably we can discuss those results during our hands-on session. So during our hands-on session, so we will see on the implementation of those assignments. Okay, so these are all the things that we discussed. Okay, so do you have any questions? Do you have any questions in any of the topics that we discussed so far?
Mm, can we also take one of the example for the event loop?
Yes, even while loop also, yep, we can see that in the virtual machine class. So we can see how we can implement the while loop. So did we had a hands-on? So because I don't remember what was the last class and what was discussed. So is it a hands-on session? So did we had a hands-on session? Do you remember?
No, we have this conduct IT session.
Oh, okay. Is it okay? Okay, okay, okay. Fine then. Fine then. So today we can have the hands-on session along with dynamic parameters and the resource pooling. Okay,
Yeah.
fine. So anything else? Anything else? So other than this, do you have any other questions?
No.
Okay, fine then. So then probably we will see the dynamic before this dynamic parameters, right? So we need to understand the rollback and recovery mechanism. Okay, so we'll see about this rollback and recovery mechanism in the conduct IT plans. Okay, so say for example, if there is
Yes.
a plan failure, okay, plan job failure. So there are two feasibilities, right? So one is restart from the beginning, and another one is continue from the last checkpoint, right? So restart from the beginning and continue from the last checkpoint. So if we have to restart from the beginning, so what we have to do to restart from the beginning? So if you have to restart the job from the beginning, so if it is a graph, what we normally do, and if it is a conduct IT plan, so what we should do?
Mm, if it's a graph, then we'll roll back the file.
Correct. So we roll back
Yeah,
the file using m underscore rollback d, and then we just
roll
execute
back.
the, yeah, right. So we can use the
Yeah,
same for conduct IT plan as well. So we can use m underscore rollback hyphen d. So then can run, we can specify the recovery file name. So after this, so we can run the plan using r sandbox run command. R sandbox run, so run the plan name. So if I have to continue from the last completed checkpoint, so how do we do that? So if it is last completed checkpoint, so last completed task. So in graph, it is last completed component, right? So here it is last completed task. So if I have three tasks, so the first task gets completed and there is a failure in the second task. Whenever we restart, so it will start from the second task. So if you have to continue from the last completed checkpoint, what we have to do for continuing from the last
There
completed
are
checkpoint?
commands
Mm.
plan admin start.
No, plan admin start is not required here. So we can continue directly from the last completed checkpoint
Eh,
just by running. Yeah, that's why we need to keep the recovery file and we have to run it with the recovery file. So if we run it with the recovery file, right? So from the
okay.
recovery file, it get the information with respect to where which task gets failed and from where it has to start. So that informations are available in the recovery file. So it gets the required details and it will start from the last completed task. Yep, that's right. That's right. So these two are the important things that you have to understand. So the next thing is on the dynamic parameters. So to start with the dynamic parameters, right? So in the graph, okay. So in the graph, say for example, we have a graph level parameter. So effective date. So if I have to change that effective date within the component, and say within one component, I'm going to change the effective date, and the same changes I need to reflect in all the other components. Will it be feasible in Ab initio graph? Will it be feasible to change this effective date parameter, which is defined at a graph level, and make use of the updated date value in another component? So we are going to do the changes in one component. The changes, what we did in one component, we are going to use it in the other component. So is it feasible first in the Ab initio graph? Hello, Sugas, I'm not able to hear you.
Yeah, okay. Uh, I'm not. I didn't get your use case actually.
Oh, okay, okay.
That
Yeah. I can repeat. I can repeat. Yeah, I can repeat. So you have a graph. Okay. So in the graph, there is a parameter called effective underscore date. So the effective date parameter. So we are going to change that value within the component inside a graph. So say for example, you are using a reformat. So within the reformat, we are going to change this effective date value, and after doing the changes in the reformat component, so we are going to have a rollup component next to the reformat component. Can we make use of the updated value, whatever the changes that we did in the reformat in the rollup component, or is it only the graph level defined value we can access within the rollup component?
we'll have to get that updated at each and every component. That
So you have
reflected in
a
an
graph level parameter,
yeah.
right? So you have a graph level parameter effective underscore dt. So let's say which is having a value as 2023 0317. Okay, this is the value which is available, which we define it as a graph level. So we within the job, so we have an input file component. So after this input file component, so you have a reformat component, and after this reformat, we have a rollup component. So then after this rollup component, so we have an output file component. So now within this reformat component, so what I'm doing is, so I'm changing this effective date as 2023 0318. Okay. So now within this rollup component, so I'm assigning this effective EFF underscore DT to a column in the target. Okay. So now you can tell me in the output file, what is the value for this effective date column? In the output file, we have a column called effective date. So what is the date value that we have for this effective date column in the output file?
Whatever we have it in the roller.
Okay, so yeah, what is the value? So I have given the value, right? So it is just a direct mapping. In the rollup, it is just a direct mapping. So whether it will have the value as, so we
So
have two possibilities, right? So
it is
whether one is 17th or 18th of March. So what should be the value that
18,
we get?
18.
Are you sure whether we get 18?
Okay, it's effective date, then it will take the value from the parameter only.
Right, it is more of a static parameter only. We cannot make the parameter as a dynamic with respect to
Okay,
the graph.
okay,
We
okay.
cannot do that, right? So we cannot do that if it is a graph, ab initio graph. But if it is an ab initio plan, okay, if it is an ab initio plan, so within the task we can change the parameter value and we can make use of the modified value to the next task. Okay, so we can do that with the help of the dynamic parameter functionality, which is
Yes,
available in the conduct IT. We can do that. Okay, so this dynamic parameter is nothing but, so we can change the parameter, we can change the plan parameter inside the conduct IT plan task and make use of the updated value. Okay, and make use of the updated value in the task next to the modified task. So we can do that. Okay, so we can do that. So how do you do that? So with the help of a command called plan admin. So we have to use a command called plan admin. So we have to specify, we have to use this command plan admin. Then we have to say set. Then we have to specify the parameter name and we have to give the parameter value. So 2023-03-18. So let's say, so you have an graph task. So after this graph task, you have a program task. So in the program task, you are changing this effective date value as EFF underscore DT as 2023 03 18. Okay. So at a plan level, it is having a value as, okay, so at a plan level, so EFF underscore DT as 2023 02 17. Okay, at a plan level, it is defined as 2023 02 17. So within the program task, so we are changing this effective date parameter. Okay, we are changing this effective date parameter as 2023 03 18. So after that, so you are going to have a graph task. So and you are going to have another program task. So now, so since we made the changes, so since we made the changes to this parameter using the plan admin command, since we made the changes using this plan admin command, and also we defined this effective date as a dynamic parameter in the program task dynamic parameters tab. So now, for the graph task and the program task, the effective date value will always be the latest value, which is going to be 2023 03 18. So that will have the latest updated value. It will not have the plan level value. So where you can change the value of the parameter at the runtime by making use of the plan admin set command, which is available in the conduct IT task. So within the conduct IT task, so we can change the parameter at the runtime and we can make use of the updated value in the next set of task. So is this clear? This is very, very important.
yes.
How do we do that? How do we do that? So we have to create a plan level parameter. So first thing is, so how do we do that? So the next is, how do we do that? So we have to define a plan level parameter. After defining a plan level parameter, so in the program task, so we have to use the plan admin set effective date and we have to give this. So along with this, okay, along with this, so we have to go to, this is very important, along with this, go to dynamic parameters tab. So there is a tab, okay, so in the task organizer, not in the task, in the task, if you open the program task, you will have different tabs, right? A description, then parameters, then you will have the dynamic parameters, resource, methods, right? So you have to go to the dynamic parameters tab. So in the dynamic parameters tab, so from the drop down, so you will have a drop down. So from the drop down, so we have to select the effective date. So that the effective date will be configured as a dynamic parameter so that the effective date value will get changed within the program task and the modified changes will be used in the subsequent task. Okay.
Yes.
So is
Yes.
this clear? Right.
Yes.
So this is how it behaves in the regular task. Okay, this is how it behaves in the regular task. So what we need to understand is how this dynamic parameters will behave in the subplan. Okay, so that is very important. So this is if we don't have a subplan, so this is how it behaves. Okay, so say if we have a subplan, okay, if we have a subplan, so we need to see how it behaves within the subplan. Okay, so how it behaves within the subplan. So we will see on how it behaves within the subplan. So
Okay.
let's take this example. Okay, let's take this example. So I think this example is similar to whatever we discussed. Probably we can see this once. Okay, so say you have a wait for file task. Then you have the program task. So where we are changing this test underscore, we are printing this test underscore dynamic. So test underscore that dynamic is defined as high at a plan level. So we are printing this value. So here it is high, and you have a program task. So in the program task, so we are changing this value as hello. So whenever you change this value as hello in the conditional task as well as in the another task, the value will always be hello. Okay, the value will always be hello. So now, so this is similar to whatever we discussed, right? So now coming back to the scope. So the scope is more with respect to the subplan. Okay, the scope is more with respect to the subplan to see how it works within the subplan. Okay, so the scope is to discuss on the subplan to see how it works within the subplan. Okay, we will see how it works within the subplan. So to start with, right? So let me go to this. So here to start with. So for the dynamic for the scope of the dynamic parameters. So let's take this use case one. Okay, so let's take this use case one. So if we take this use case one, okay, so if we take this use case one, so let's say you have a plan, okay, you have a plan. Within a plan, so you have a graph task, then you have a subplan task. So and you have another graph task, okay, and you have another graph task. So within the subplan, okay, within the subplan, so you have a task, okay, you have a task. So where you are changing the value of m3, okay, so we are changing the value of m3 or a3. What is that? It is m3, okay. So let's say m3, okay, m3 is having a value as hello, okay. Let's say m3 is having a value as hello at a plan level. Okay, m3 is having a value as m3 is having a value m3 is having a value as hello at a plan level. It is having a value as hello at a plan level. So you can tell me what is the value in the task one. So in the task one, so what is the value of m3? So in the task one, so what is the value of m3?
We are setting the value as a hello, right? Using a
Correct.
dynamic parameter.
Correct. See, no, at a
So it
plan level, we are defining the parameter with the value as hello. So in the task one, if you see what we are doing in
hello,
the
hello,
plan
hello.
level is hello. Yeah, we are just printing it. So it is hello. That's right. So now the next thing is, so the subplan. So within a subplan, so let's say subplan dot task A. Okay, so subplan dot task A. So within the subplan dot task A, so we are changing this parameter. Okay, we are changing this parameter as world. Okay, we are changing this parameter as
Mm,
world. So now let's say within the subplan dot task B. So if I try to print the value of M3, so what is the value of M3?
world.
That's correct. So
Okay.
it is world.
Yeah, world.
Yeah, it is world. That's right. So if it is task two, okay, if it is task two, so what is the value of M3? So this task outside the subplan, outside the subplan. So what is the value of M3?
Again, hello.
That's right. They are right. So the scope is only within the subplan. Okay, the scope of parameter is only within the subplan. So we cannot extend the scope. We can extend the scope. So probably we'll see how to do that. But for now, right? So this is how it works. So within the subplan, so whatever the override that we are doing, so that is
Okay.
accessible only within the subplan. Okay. So we need to see now how we can make this world accessible for the next task. So can you tell me how we can make this world accessible for the next task, next set of tasks?
Mm, we that parameter should be defined as a dynamic in the dynamic tab.
Dynamic parameter, yeah. So currently the parameter is defined as a dynamic parameter in task A. So in task A, it
Task.
is defined as a dynamic parameter. So
Okay.
now, so since it is defined in the task within the subplan, so that is the reason so it is accessible only for task B. Okay, so it is defined as a dynamic parameter only in the task A. It is defined as a dynamic parameter in the task A. Since it is defined as a dynamic parameter in the task A, it is accessible only for task B. So if you want this world to be accessible for the next task after the subplan, can we make this as a dynamic parameter as a subplan level? So we have to make it as a dynamic parameter at a subplan level. So if you are making it as a dynamic parameter at a subplan level, so then you will have that value retained in the next task. You can make use of that value. So I will tell how to do that. I'll tell how to do that. So here for the task A, so we are setting M3 as dynamic parameter and override the value. Okay. So now coming back to this case 3 example. Okay. Now coming back to this case 2. Now coming back to this case 2 example. So here what we are doing is, so let's say, okay, so let me put it this way. So I think it is not hello. Okay, so I think we used hello only, right? Yeah, we used hello only. Okay, fine. I don't want to confuse. So it is the same. Okay, it is the same. So just only thing is, so we are going to define the setting of M3 as a dynamic parameter at a subplan level. So instead of doing it here, okay, so instead of doing it here, so we are going to keep it we are going to keep it as a dynamic parameter and override the value at a subplan level. Okay, so at a subplan level. So we are going to do it at a subplan level. So in order to do this at a subplan level, okay, in order to do this at a subplan level, okay, so we will see how we can do this at a subplan level. So for doing this at a subplan level, okay, for doing this at a subplan level, so what we have to do is in the subplan, so we have to right click and then we have to go to dynamic parameters and then we have to set the M3 as dynamic parameter. So once you set this M3 as a dynamic parameter, so now tell me what is the value in task 2. What is the value of M3 in task 2?
World.
Yes, that's correct. So it is going to be the world. So because we have overridden the value, we have set this value as a dynamic parameter at a subplan level. So we have set it as a dynamic parameter at a subplan level. So if you are making the changes to the task, the same changes will get reflected to the next set of tasks available after the subplan. So whatever be the tasks which are available after the subplan, so we'll make use of for the will make use of the overridden value. We'll make use of the overridden value. Whatever the value which is the latest value, it will make use of that value. So is this clear? This is very, very important. Is this clear? Yeah, is this clear, Suhas? Do you have any questions?
No, no. I'm just checking at the case two.
Yeah. Please, please, please. Yeah.
Yes. No, no, no questions.
Okay, fine then. So these are all the things that we have to understand with respect to the dynamic parameters. So now we will move on to the resource pooling functionality which is available in the Conduct IT plans. So to start with, right, so this resource pooling, so it is a feature which is available in the Conduct IT to restrict the resources, to restrict the concurrent execution. It's basically to restrict the concurrent execution of conducting jobs by setting the maximum concurrent limit for resources. How we are going to do that? So you will see. Okay, so where we use this first, what is a resource pool? So using the resource pool, so we can restrict the concurrent execution. So we can restrict the concurrent execution based on the maximum limit that we have set. So say for example, so you are trying to run 10 psets. So out of the 10 psets, and if you are running all the 10 psets concurrently, so all the 10 psets will make use of the system resources, right? So what we can do is, so we can set the we can create a resource pool, and we can create a resource within the resource. So we can set the concurrent max concurrent limit as 5, and we can make use of that resource pool within our conduct IT task, so that we can have only 5 instances actively running in the run host. So the remaining 5 instances will be in the queue. Remaining 5 instances will be in the queue. So only the 5 instances will be active. So and it will be executed from the run host. Okay. So is this clear? Any questions?
Okay. I
We'll see an example. I think we will when
resource
we see
pool.
an example. Yeah, yeah. When we see an example, it will be much more clear. That's right.
No, no, yeah. Okay. Sure.
Right. So with respect to the application, right? So we can use the resource pooling uh, to limit the number of connections to databases, number of connections to databases. That is one application. So the next one is to limit the number of connections to the remote service, and also to limit the CPU utilization by having the maximum concurrency limit set. Okay, so these are all the different applications of the resource pool. So these are all the different applications of the resource pool. So we can use resource pooling in all these applications. So we will see how do we do that. Okay, so the next thing is how do we do that, right? So we can restrict the concurrent execution using the resource pooling. Then we need to see how do we do that. So first thing what we have to do is we have to create a resource pool. So in order to create a resource pool, so we have an option to create a resource pool. So we can go to the resource menu. In the resource menu, there is an option called new. We have to go to the new, and we have to say new resource pool. So when you say new resource pool, so it looks like this. Your dialog box looks like this. Okay, your dialog box looks like this. So within this dialog box, so we can add new resources. Okay, we can add new resources, and we can set the maximum limit for that particular resource. So in order to add, so what we can do is we can just go to file and then new, and we can create a new resource. So let's say if I'm creating a new resource called a CPU to control the concurrent executions of multiple jobs. So we can set CPU, and we have to set the maximum number of units. Okay, we have to set the maximum number of units. So here the maximum number of units is so 4, which means so it allows only 4 concurrent connections. Okay, it allows only 4 jobs to get executed from the run host, right? So and the fixed size. Okay, so here I have mentioned, so file new resource name. The resource name is going to be FTP, and the number of units. The number of units is nothing but maximum allowed concurrent connections. Okay, maximum allowed concurrent connection. So and by default it is fixed size. Okay, by default it is fixed size. What do you mean by fixed size? So when you specify this as a fixed size, so why it is a fixed size? So when we say fixed size, what is fixed and what does it mean?
Uh, that many only we can restrict.
Correct. Yes, it is more of a static. So when you say fixed, it is a
Yeah.
static. So we cannot change the maximum allowed concurrent connections at the runtime. We cannot do that. So if we want this to be dynamic, okay, if we want this to be dynamic, say for example, so say today the maximum limit can be 4. So based on the load, we can increase the maximum limit to 10, right? So if the load average is less, so we can increase the number of concurrent connections, right? So we can increase the number of concurrent connections. So if we have to do that, so if we are going to do that, so then we have to uncheck this fixed size. So uncheck the fixed size. So uncheck the checkbox, checkbox of checkbox in fixed size. Okay, so we have to uncheck the checkbox in fixed size. So if we are going to change the maximum allowed concurrent connections dynamically. Concurrent execution value at runtime. If you want dynamic, so then we can uncheck the job. So if it is more of a dynamic, and if it is fixed size, so it is static. So we cannot change the maximum number of concurrent iterations. So if it is a dynamic, okay, if it is a dynamic, so then how do I change this maximum number of units? So we have an option called we have a command, okay. So for plans, we have for dynamic parameters we have plan admin, right? So for the resourcing, we have a command called resource admin. So we have a command called resource admin. So resource hyphen admin. So we have an option called adjust. Okay, so resource admin adjust set CPU. So yeah, CPU is the one, right? Set CPU. So for the CPU, so see if I want to increase it, so we can increase it as 6. Okay, we can increase it as 6. So like this, we can change this maximum allowed concurrent connections at runtime using the resource admin adjust command. So when you are unchecking the fixed size option, is this clear?
Yes.
Right. So now, so the next thing is, so we have created a, so the next thing is we have to save this resource pool. So we know how to create a resource within a resource pool. The next thing is how to save the resource pool. So whenever you click the save option or file and then save as option, it will ask where I have to save this particular resource pool file. So you can store this under the resources directory. So under our sandbox, we have this resource directory, right? So under the resource directory, you can save this resource pool file. So you can just say file savers, then within the project there are project dir resource, then you can say you can specify this, you can give any name for the resource pool, and then you can save it under the resource directory. Okay. So once you save this resource pool, how do I use this resource pool, right? So the next question that comes to our mind is, so I have saved the resource pool. So if I have to make use of this resource pool, so how do I use this resource pool? How do I use the resources within the resource pool inside a task? So inside a task, so for dynamic parameters, we have dynamic parameters. For resource pool, so you have a tab called resource. You have a tab called resources. So in the resources tab, so you have a pool name. So from the pool name, so we can select the resource pool that we have created. So which is a development resource pool. It's a dev underscore resource dot pool. So we can select that particular resource. So after that particular pool, resource pool. So after selecting this pool, so we have to specify the resource. So the here in this example, the resource is going to be a CPU. So we can set the CPU, and we have to set the limit. Okay, we have to set the limit. So I will tell about this limit. Okay, so for now the limit is 1. Okay, we have to set it as 1. So you can set the limit as 1. So once you set this as 1, okay, once you set this as 1, so then uh, okay, once you set this one, so say for example here in this example, so the maximum allowed unit is 3, right? So maximum allowed units is for the north extract or south extract is going to be 3. Okay, maximum allowed units. So if I set the limit, if I set the units required, it is more often units required. Okay, units required. So if I set this units required as 1, okay, if I set this units required as 1, okay, if I said this units required as 1, okay, if I said this units required as 1, so when we said this units required as 1, So it allows three concurrent connections. Okay, it allows three concurrent connections. It allows three concurrent connections. So say for example, if we are trying to establish six parallel connections, okay, if we are trying to establish six parallel connections, so out of six parallel connections at any given point in time, so it allows only three connections. Okay, it allows only three connections. Allows only three connections. The remaining three will be in the queue. So once the three gets completed, so then the next set of three will be active and it will get executed. Okay. So is this clear? Any questions?
So this that maximum one will be we will be defining in the resource pool while creating it, and here the unit that we have it in sorry, the resource tab, in the resource tab we are defining it as a one.
Correct. Unit required as one. Units required for this particular
Yeah,
task.
yes. So how it takes, like
So
how
it,
if I define that as a two, if I define that as
yeah,
a
that
two.
is what, yeah, that is what we are going to discuss now. So we will see how it will take. So if we set it as two, okay. So let's say, so we'll take this example. So maximum number of units.
Yours, sorry. Okay. I click.
Yeah, let me scroll down. I think if I scroll down, I think you can see that better. Yeah. So let's say maximum number of units. We are setting this maximum number of units as, let's say, maximum number of units. We are setting it as 10. Okay, we are setting it as 10. So units required. Okay, units required. We are setting it as 2. Can you tell me now what is the maximum allowed concurrent connections?
Five.
That's correct. Perfect. That's right. So it is always it is like 10 by maximum number of units by units required. So units required is
Units
going to be,
required.
yeah, it is going to be five concurrent connections. That's right. The same is applicable. So when you give it as one, units required as one, so you will have 10 connections. So we can give only in whatever the value that we can match it, we can, it is
Mm,
divisible, right? It is divisible. Only that value we can give. We should not give it as
right.
three. We should not give it as three.
Oh,
So
okay.
the three will not work. Yeah.
Okay.
So clear? Is this clear? Any questions?
No. My only question will come over here, like, see, when we define this the resource pooling, or when we creating this resource pooling, how we come to know about the resources in the system, how many resources we have it, because according to that we'll have to define the maximum number of max
Units. That's correct.
units. Okay,
That's
so
correct. So that is more with respect to what it is more of the analysis that we have to do based on the current utilization in the production server. So what we have to do is we have to get the utilization report from the production server. So based on the current utilization, so we need to come up with the based on the current CPU and the memory utilization. So we need to come up with the maximum number of concurrent iterations that we can allow for a particular time. So say you have a plan which is running currently. So that plan is it is creating 10 concurrent
mm,
connections. Okay, it is 10 concurrent connections to database. So during that time, so in the report, if it says that the load is high, load average is high, CPU and the main memory utilization is high. So what we can do is we can reduce the number of concurrent connections. So it is like, so if we are reducing it for a plan, so then it is applicable for that plan at any point in time. So it is not like we cannot do it for multiple time frames. So that is not feasible. So if I set it for a plan once, so then that is the case for the entire day. For the entire day, whatever be the maximum concurrent, maximum allowed, maximum number of units that we have given, right? So maximum number of units, the same maximum number of unit is applicable for all the runs. Okay, so it is not time driven.
Correct.
So yeah, so we
Correct.
cannot, yeah, we cannot do that with respect to the time. So we can do that based on the utilization. So we can, if we can define it once, so that can be used for all the day, for the entire day. If I have to change it, so then we have to do it once. So then after that, so we can tweak that value so that the modified value will be applicable. The modified value is applicable. The modified value is applicable for the next run. So that is how it should be. We cannot do it at a time frame basis. So based on the time where the load is there, so we cannot do that. So we can also do that, but it has to be a manual way. Okay, we can also do that by removing the fixed size. So we have an option called fixed size, right? So we have to remove that fixed size, and we need to have a script so that runs in different time frames. So say for example, so you can have a script to run for every 4 hours. So every 4 hours, so it has to reduce the load. It has to reduce the maximum number of concurrent connections. So we can set the, say for example, initial concurrent connection as 20, and every 4 hours you can use this resource admin adjust to reduce the number of concurrent connection. So in that way also we can do it to keep it at a time frame level based on the load average. So we
Okay.
can do, we
Mm-hmm.
can do at a time frame level as well. So that is also possible. Okay, so it is more of how we are designing, right? So we can do that. So we need to have a separate script. So that script should run for every 4 hours. So and the script should what the script should do is the script should just run this resource admin adjust a command, and it has to reduce the maximum allowed concurrent connections.
Yes.
Right. So is this clear? Any questions?
No, no. Yep. Clear.
Okay. Fine then. So now we'll
Yes.
move on to the next. So the next one is on the control center. Okay. So the next one is on the control center. So for the control center, so have you worked on the control center? So or is it new for?
Yes.
Okay. Okay. So we can use it for monitoring.
For monitoring or for tracking purpose
Oh,
only.
okay. You have worked on it. Okay. Okay. So scheduling it is new
Yeah.
for you, right? So scheduling is new for you.
Yeah. Yes.
Okay, we will discuss more in terms of the scheduling then. So whichever is new for you, we will discuss that. Yeah, scheduling we will discuss. So yes, Control Center is a web-based user interface, right? So it's a web-based user interface for web-based user interface to schedule the jobs and schedule the jobs and monitor the jobs, right? So you can use it for monitoring purpose as well. So with respect to the schedule and the monitoring, right? So we can see this user interface. You can see this user interface. So this is how this user interface looks like. So where you can see the different tabs. So where you can go to the schedule tab, but to create a schedule. So in this screenshot, the schedule tab is not there. So you will have a schedule tab. So in the schedule tab, so you can see the list of jobs. You can see the different jobs, right? So and you will have a daily jobs. So in the daily jobs, you will have the run of the jobs on that particular day. So where you can get the log information, error information, tracking details, right? So for getting the log information, error information, tracking information, we have to right click the job and we have to say output. So output to get the log and error, and we have to click on tracking to get the tracking details with respect to the plan or the graph job, graph task, the plan job or the graph, right? So we can view the tracking details. So with respect to the scheduling, right? So with respect to the scheduling, so we have to go to schedule. Okay. So in the schedule tab, okay, so schedule is the tab name. Okay, we have to go to this schedule tab. So in the schedule tab, so you will have an option. Okay, so on the right side corner, okay, on the right side corner, you have an option called create job. Okay, so just tell me if you want to create a job. So what are all the details that you need to create a job? So if I want to create a job for scheduling, what are all the details that we need to create a job?
schedule name
right? Job name,
when the schedule is scheduled to run, means on which
right?
days and
So
what
days and time, right? So
days
days
and
and
time.
time. That's right. What else?
Host,
Correct. So
server,
server name. Yeah. So for that, so we
server
have
name.
an we have a property called runtime environment. Okay. So we have a property called runtime environment. So this runtime
Okay.
environment will define the server and the FID, to which server and to which FID it has to connect. So we will define a runtime. So first we have to create a runtime first. After creating the runtime, and we can make use of the runtime. So say for example, test hyphen development is a runtime. So this test development runtime will have the configuration details to connect to the ABC server.com, and the user is going to be AB12345. So that settings we have to specify in the runtime environment, so that using that runtime environment test hyphen dev, so we can connect to this development server. Okay, yeah. What other information?
Mm,
Calendar,
what this
right? So
FID does?
what is it?
What this FID does?
No, no, no. Can you repeat the question?
What the FID does?
Okay, FID is more of in which functional ID this job should get executed, right? So on the server, we can have multiple functional IDs. So in which functional ID this job should get executed, so we have to specify the functional ID also. So here it is, I have specified an user ID. It's like a functional ID. So say for example, sales is your one of the functional ID. Marketing is another functional ID. So for sales, you can create one runtime environment, and for marketing, you can create one another runtime environment. Say you can say test hyphen dev hyphen sales for the sales, for running the sales jobs which are available in the sales sandbox. So for running the marketing jobs which are available in the same server, so we can create one another runtime environment. So here it is going to be my mktng. So here also you have to give mktng here. So mktng. Okay, clear.
Yeah, yeah, means
What other information? Yeah, what other information that we need? Calendar we have to give. What else?
calendar, calendar, yes. Then, 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 this is for the schedule name only, right?
Yeah, yeah, that's right. So yeah, the job name is the schedule. Yeah, for creating a schedule, for creating a job, for scheduling. So other than this,
Okay,
what other information?
okay. So I think this is sufficient for creating a schedule.
Okay,
And
okay.
what else? If I'm able to recall, like uh, no, I think this is what I can recall for schedule. For the
Okay,
job, I
okay.
think we can able to give the
So we have
dependency
to, yeah, job dependency. Yeah, with respect to the dependency, yes, we have to set it is a job level dependency. So we have to set the job. We have to specify the predecessor job details. So job level dependency, or you can set the file based dependency, right? So file based trigger file based dependency, right? So we can set job
trigger
based
based
or
dependency,
dependency,
trigger
right?
based,
So
yeah.
job based file based dependencies, right? So yeah, so and
This
also. Mm,
schedule may have the dependency also.
it can have dependency. That's right. That's right.
Uh,
And
yeah,
and we can specify. Yeah, there is one important thing that we are missing here. So we are specifying all these details. So we need to specify whether it is a plan or a graph or a
yeah,
program.
means executable, whatever whether
Right.
it's we are running it with the
Right.
plan and the p
Right.
set or
Right.
graph.
Right. Right. Right.
Yes,
Right.
yes.
Along with this, yes. So that also required. So we have to specify the sandbox location followed by the executables. Okay, sandbox location followed by the executables. We need to just give the plan name or the graph name. So if it is a program, so we have to specify the script that we are trying to execute, the absolute path of the script that we are trying to execute. So then we have to specify the type. So based on this type, it decides the executable. Okay, so based on the type, it decides the executable. So if
Mm,
it is plan, if you select it as plan, so
yes,
then you have to give a plan. Yeah, if it is graph, then you have to give graph. If it is program, you have to give a you have to provide a script file, absolute location of the script file.
correct.
Right. So these are all the information that we provide. Okay, these are all the information that we provide when we create a job using the control center. So with these information, so what we do is, so we do save and submit. Okay, so we do save and submit. So then it will go to the approval workflow. So once you do the save and submit, so then it goes to the approval workflow. So in the approval workflow, so the approver, so schedule approver, so can approve the changes or reject the changes. Okay, so if he approves the changes, so then the job becomes, so job becomes active, job becomes active, so job becomes active if it is approved. If it is rejected, so then job gets, job status changed to edit mode. Okay, job status changed to edit mode to make the changes. Okay, so change to edit mode for making the changes. Okay, for making the changes. So your the job, when you so when you, if it is approved, so if it is approved, so then job becomes active if it is approved. So job status change to the edit mode for making changes if it is rejected. Excuse me. So this is the workflow that we have to follow. So for approving a job or rejecting, so we can also do. Okay, so we can, as a user, we can approve or reject the changes. So, but ideally, they have created a workflow in such a way that, so say to have a peer review. So one person can do the job creation, the other person can do a peer review, and then he can approve the job, right? Approve or reject the job to make the changes. That is how they have designed this workflow. Okay, clear?
Yes.